with low energy, like a beacon solution or a Wi-Fi based solution, or if you need to transmit the data to a longer distance using wireless, then LoRaWAN, or again to a longer distance, then upcoming technologies NB-IoT that we will discuss in quite few minutes. So before going to the topic, we need to understand what is meant by IoT. So IoT means you all know very well about the abbreviation Internet of Things. So by this picture, you can be able to clearly understand that each and every devices is connected or transferring the information from one device to the another device with the help of the key connectivity factor called internet. That's what the hardware is nothing but we will tell the point as things. Here the hardware is nothing but things. It is going to transfer the information, and how it is going to transfer the information means the connectivity is internet. That's what it is called as Internet of Things. You can able to see you can have a smart locking system, smart remote control, and even in your laboratory or not laboratory, in your HOD room, you can able to see one laptop or a PC is connected to one of the printer, but printer as well as your PC or laptop is not connected through wire. Previously it is connected through RJ45 cable. Now it is through a wireless communication. Whenever we are giving print, then within the vicinity, your printer is start going to work. That means your printer as well as your device is going to talk each other. That is the sharing of information. This is called as Internet of Things. Quite you can visualize in your college. And again, we need to discuss about the IoT architecture. Here, you can able to see two types of architecture. One is existing, and another one is emerging. So we will keep the aside the emerging technology because that is still in R&D. That is not into the deployment phase. Deployment means we need to design the solution for the problem statement, and we need to install lively. That is called as deployment. Okay. And again, in existing stage, you can able to see there is three sub categories. One is direct integration pattern, another one is gateway integration pattern, another one is cloud integration pattern. But we are not going in depth about the integration pattern, but quite a few words I will explain about this one. Here, as I already told, a thing is nothing but okay. We will take one use case. So you take an example of one agriculture land. See, this agriculture land is around some 40 acres around the vicinity. Okay. So what I need, I will tell the use case. Okay. I need to measure the soil moisture and the soil temperature. You can able to see here the wire is going and inserted in the soil. Okay. In the soil. And we need to get the parameters called soil moisture and soil temperature. Okay. After getting the parameter, obviously we need a microcontroller in order to process the data. Am I right? Okay, after processing the data, here I need to enable the IoT in this open space. How we need to enable the IoT for this open space? This is an agriculture land. Okay, what are the possible ways to enable the IoT? And moreover, are you thinking whether wired communication is possible? So if it is a wired communication, that means I need to send the data to the cloud, and you need to think this is the use case. Okay, I need to get the parameter values, and based on the soil moisture and the soil temperature, I need to that means I need to switch on the irrigation. You can able to see the below here. Here we kept the flow meter, and here you can able to see the solenoid valve, or you can able to see here solenoid valve in order to automatically switch on and switch off the irrigation. And here the flow meter, how much water is flowing into the particular pipe. So all these measures we need to take care, because we need to increase the yield of the crop. That is the final outcome of this project. Okay, then what kind of solution is best in order to give for this use case? How to transfer the data? So the possible ways of transferring the data is either you can use Wi-Fi or Bluetooth or Zigbee or other long distance communication. Okay, LoRaWAN. Then you need to understand again Bluetooth. If you are taking a Bluetooth, say let us assume two members. Okay, If two members are there from one phone to another phone, if one person is sharing the data to another person, how much distance it is withstand? Or otherwise, best example is your wireless headset, earpod along with your mobile. Okay, so after configuring or after pairing your mobile phone with your headset, okay, you are keeping your handset in one of the room, and you are going for a bedroom or a kitchen, okay, or some other, or you are going some outside of your room wearing headset, okay, then you are playing a song. Let us assume how much distance you can hear the song, up to one room or another room, that's all. If you are going somewhat, then obviously there is a signal disruption happens. Then if again the distance is more from the handset to your headset, then obviously this data transfer will be disconnected. Okay, this is the drawback of wireless communication. The distance is the main drawback of wireless communication. And if you are going for another wireless communication, Wi-Fi, then obviously the distance will be more, but all these are in terms of meters. Okay, but if you need to transfer the data to your kilometer, see here, around 50 acres of land means you can think how much distance it need to cover. Okay, so you need to go latest technology called LoRa or LoRaWAN. We will tell us long range communication. But here we are not going to in depth about what is meant by LoRaWAN and how to work and what is the use cases. But general, as a general discussion, we are doing here. Since it is a LoRaWAN, long range communication, it will transmit the data up to 10 kilometer radius. Okay, that means for all the 50 acres, if you are in terms of kilometer, if you are checking, that will be around 5 kilometer to 6 kilometer. That's all, the entire distance. Okay, so for LoRaWAN, we have a special gateway in order to receive the packets and in order to convert the packets into IP. Okay, that's what LoRaWAN plays a major role in smart city applications. Okay, so this is what I came to explain. This is the rod we have deployed in the or buried in the soil. So actually you can able to see here the wire. Okay, actually we kept the sensor inside the soil. Okay, the sensor will look like this. This is the soil, and this is we are connecting this microcontroller. But for understanding of this, I have kept the picture of Arduino, but we are using STM32 for reliability as well as the low power consumption, because we are going for battery operated. You can able to see here, you can able to think whether routing of 230 volt power supply to each and individual boards is possible. See, for all 50 acres, routing the wire to 30 volt, what happens if there is any cut in the middle? Then obviously it will leads to a miserous outcome. Okay, so these are all battery operated. Okay, since it is a battery operated, we need to be very careful in the design to save the energy. Okay, because one time if we are deploying this kind of solution, at least 1 year without touching, we need to get the data. Otherwise, if daily I need to recharge like your mobile, put charge your daily you are playing in mobile, you are speaking with your mobile, and you are surfing the internet, then obviously how much usage you are doing, then power also it will reduce, charge will reduce. Then since you can the power bank is with you, then you can able to fully charge your handset, correct? But solution like this daily, say I'm in Pondicherry or in Bangalore, this is deployed in Rajahmundry, Andhra Pradesh. Okay, daily I can able to travel from Bangalore to somewhere else, or you can able to assume you are in Pune example, and your client is in Delhi. So it is your client project is in Delhi. Daily you can able to travel to Delhi in order to put the charge? No. These are the different thing, design thinking are there for deploying the IoT solution. Okay. So in this, what I'm going to claim here is direct integration pattern means the hardware, sensor as well as hardware will directly able to transfer the data to the cloud. Okay, but gateway integration pattern is nothing but different hardware or different kind of say for example, I will again, okay, this is hardware number 1. See, this is deployed over here. This wire is going here, and we have inserted the soil moisture and sensor. This is sensor number 2, and we have deployed over here. This is one field, okay, and this is one field. This we are segregating, okay, field 1, field 2, field 3. You can able to see here 1, here 2, like that. The signboard also there. Like this, different hardware will transfer the data to the gateway, and from the gateway the data will be routed to the cloud. But this also based on the costing parameter. Okay, so based on the costing, we will go with what kind of integration pattern will be best for this for any kind of solution. Again, cloud integration pattern, it more or less resembles the direct integration pattern. The only thing is for enabling the security. Okay, because in IoT, security also important factor, because someone in the middle is going to hack your data, and you can able to do the forgery, right? So in direct integration pattern, the security is available in the device side, but in cloud integration pattern, the security key will be available in the cloud side. So actually, where we are going to save the data? In the cloud. So how we need to safeguard the cloud? With the help of some different key mechanisms. Okay, so by this different integration pattern varies. Okay, and these are the hardwares available in the market, and this is regarding 4G module. So the direct integration pattern, you can able to see the thing directly sent to the cloud. That means whatever the sensor data we are getting, with the hardware itself, we will embed the 4G module, like your mobile phone. Each mobile phone or each handset have 4G module, correct? Then in order to communicate with your friend, okay, then what you will do, you will go to the shop, Airtel as well as Jio. You will buy one SIM card, you will insert, and you will start to communicate with your friend. Okay, and if you need to use the internet without a third party like a Wi-Fi, again you need to put the data pack. So that is called as direct integration pattern. But gateway integration pattern is nothing but sharing the data. See, again, in your handset, there is no SIM card present. Then you need to use the internet. Or a best example is your laptop. Okay, because in laptop there is no option called 4G. Okay, how you are using internet to you with your laptop? With the help of Wi-Fi. And again, how you are getting the hotspot? With the help of your mobile phone or some hotspot. Okay, Wi-Fi hotspot. This is called as gateway. Here in IoT technology, we will call that one as a gateway. It is a relation between the base hardware or physical layer to the cloud. Okay, this is the intermediate layer which will get the data from the physical hardware, and it will send the data to the intended cloud. Okay, so in order to experiment this, we have come across one multi-layer, or otherwise called as multi-controller with multi-wireless technology to in order to understand from embedded system to the IoT. So from basics to the advanced level. So you can able to do n number of experiments with this. Let us explain individually. So in this you can able to see. In this you can able to see we have kept a Arduino Uno. Next one is Raspberry Pi Pico. Next one is ESP32 and STM32. Why we kept 4 different? This is one kind of product development. That aspect also I will cover. Okay, so you need to understand why we kept different microcontrollers in a single platform. Actually, whenever we are doing a product development, you need to come out of the box thinking. Okay, actually, you can able to see whatever the product you are seeing, that is made up of only one microcontroller. But if you are going for the job skills after completing the final year, in the job recommendation itself, they will expect students need to learn Python, students need to learn embedded C, students need to learn different wireless protocol, students need to learn different microcontroller bits. Say for example, 8-bit microcontroller, 16-bit microcontroller, 32-bit microcontroller. Okay, so if you are keeping all this in a single board, then students will learn from basic to advanced. That is the concept of product development here. So we kept 8-bit microcontroller as Arduino Uno and the Raspberry Pi Pico. Next one is the ESP32 and the STM32. These two are 32-bit microcontroller. This is point number one. Next one, in Arduino, this is well established in educational institution. Why? Because lot more libraries are available. Then students need to interface the sensor. They need to install the library and they need to extract the sensor data. Correct? So that's what. So basic thing required in order to make your hands dirty or make you as an embedded engineer, then you need to start with Arduino. But you need to go with the advanced level, then you need to go with the STM32, because in STM32 each and individual line you need to write HAL programming, hardware abstraction layer programming, but that is based on embedded C, but that requires some extensive knowledge of C programming. But in why we are keeping this one means in product development we will use STM32 based, whatever we are giving to the client. This is one of the product, right? We will give with the help of STM32 based microcontroller. As actually I told no, because the reliability, once we deployed at least 2 years or 3 years without any problem, it need to work. That is the reliability. Another one point is power consumption. Since we are operating with the battery, okay, then power consumption also an important factor while designing a IoT product. Okay, so that's what STM32. Okay, and quite familiar here, since you understand 8-bit and 32-bit microcontroller, then you can learn two types of programming language here, embedded C language as well as Python. So it will meet to the industry requirements. Whatever industry is expecting to the final year students, this kit will meet. Like that only we have designed this kit. Okay, so here with the help of embedded C as well as Python, we can program all the 4 microcontrollers. Then what is the essential things for IoT communication? The essential thing is connectivity. So connectivity in the sense Bluetooth low energy. Next one is Wi-Fi. Next one is LoRa. Next one is GSM. Okay, different wireless connectivities are there. So using ESP32, there is a onboard Bluetooth communication, Bluetooth low energy communication. The difference between Bluetooth communication and Bluetooth low energy is the power consumption, because power is important in terms of IoT products. Okay, so if say for example one Bluetooth energy is Bluetooth communication is taking 1 milliampere to transmit the data, means Bluetooth low energy will take some 100 microampere. See, around some 1000 volts it will reduce the power consumption. Okay, in order to make the device to prolong up to 5 years with a lithium or coin cell battery. That is the advantage of IoT. Okay, and apart from that, Wi-Fi is there in order to transmit the data. If you need to experiment some long range communication, then we have kept the LoRa module also. So here you can experiment what is meant by LoRa, point to point communication, as well as LoRaWAN, so wide area network, and you can able to transmit to a longer distance, say in terms of kilometers. Okay, then if again you need to work on GSM based, then here we kept a 2G module. You can able to send as an SMS, triggering SMS, or in terms of automation, it is very much useful. Once, say for example, we will assume another use case, cement factory. I think a Prism cement factory, you know, in the northern region, and in southern region, Dalmia Cements, you know, that is located in Salem in Tamil Nadu. Okay, we have deployed a pilot project over there that is called as damper control. That means 3-phase damper control. Once the particular cooling temperature reaches, then automatic. Hello. Okay. Once the particular cooling temperature reaches, then automatically the damper should be switched off. That is based on control. If there is a miss or there is a failing happens, then we need to get the initial trigger SMS. Okay, so for these cases we will use the GSM module. Okay, and as I told, for automation, for damper control, I told no temperature and humidity, and based on that damper need to be controlled. So here we kept
Mr. Karthikeyan, we have last 10 minutes.
Okay, okay, ma'am. I will complete. Okay.
Okay.
So you can able to see here, we have kept the onboard temperature and humidity sensor along with the two relays. So to any 230-volt appliances, we can able to control here. Then here we kept a RGB LED and a few more onboard sensors, accelerometer and gyroscope sensor, as well as the pressure sensor. Okay, it is not limited to only this. If any kind of sensors, okay, soil moisture sensor, IR sensor, ultrasonic sensor, or pressure sensor, or water meter sensor, or current sensor, any kind of sensors we can interface in this board. Okay, then again, apart from wireless, there is a wired communication also, because for us industry 4.0, that is based on RS485. Previously it is RS232, that also we kept, and nowadays due to standardization, we need to work on RS485 data, Modbus. We will tell us Modbus. That also we have kept. This is based on wired communication, RS232, RS485. And in automobile industry, CAN communication is going on. So CAN module also there. So this is not limited to only few experiments. Any type of experiments we can do. Once we are experimenting this your ideology, then we can go with an individual product development. Say this is one of the product readily available in market. Example, LoRaWAN based temperature and humidity sensor. Once you are start thinking about the product development and experimenting with the development kit, then you can able to design your own product and you can able to launch in the market. You can able to see in the single package, there is a temperature humidity sensor and the gassing is IP67. Whenever you are keeping outside also, based on the environmental factor, it should not affect. Okay, and you can able to see the battery which is kept inside. It is around 12,000 milliampere, and they are giving the connectivity. That means the data transfer up to 5 years. Okay, with that battery. Okay, like this also you can develop the product, and there are different use cases for individual products. Say the temperature and humidity sensor, you can able to think in the greenhouse, or you can able to use in the food storage, or monitoring purpose, even machine rooms, in medical storage, cloud storage. Okay, different kinds of applications are there. In order to create the application, you need to work on the concepts. Once concepts you are once you are keen enough with your concept and experimenting the output, then obviously next product development will start, and you can able to design your own product and launching in the market, and you can do it your marketing. Okay, I will show the video of this kit. So we are, as I told, we are coming out of a traditional way. So we created as a laptop kind of model, because a traditional kit will look in a wooden box. It is like a laptop kind of model. This is a demo box, but there is a engraving all there while delivery. So Arduino Uno. So this is the complete board. So if you have any clarification, you can ask me. If you have any clarification, you can ask me so that I will answer to your queries.
If anybody have any query, please raise your hand so that I can give option to open your mic. If anybody interested to ask, please the hand raise. Kshitij was writing. Kshitij. Okay, Kshitij, you can ask the question. Please ask your question, Kshitij.
Okay, ma'am. Sir, you spoke about the wireless communication, where you talked about the range of any wireless medium. So I was talking about like in my friend's home. He has a big home. So the problem with his home is he has a geofiber connection at his home, and the problem with his home is because it's a big some room at the corner. He has problems getting the range there for Wi-Fi. So what he did was he installed a Wi-Fi extender. So what does it do is it extends the range of the wireless frequency is getting. So how is this different from like having a hotspot at center and extending it radius rather than just using an extender? So is it helpful? Can we do that?
Actually, yes. Actually, you for home we can use Wi-Fi, but if you are going for large scale deployment, again the extender you need to think how much distance it will cover. Okay, see for this use case, okay, this is a open space around 5 kilometers. Again, you need to think for extender also we need to give 230 volt. Am I right? In order to power up. So how many 230 volt in this field I need to bring it up? That is the problem. Okay, only one gateway, that means I'm powering with 230 volt. That is fine enough for this entire field. But if I am going to for multiple routers in this land, then for multiple gateways or multiple extenders, I need to power up. Whether it is suitable for this open space, that is with water. If it is home, it is fine. That's what. Based on the use case, we need to identify the solution, IoT solution. But extender, it is good for a household, but not for a complete deployment. Are you understanding?
Okay, Rishabh, you want to ask? But we have only 1.5 minutes. Rishabh, you asked fast.
Okay, sir, my doubt was, as you said, we will be using ESP module for most of our projects. Sir, but what are the other than ESP module we can use, and can we make a specific purpose microcontroller? And also,
Yes,
if
sir.
I want to pursue my dive deep into this IoT term, so what more technologies should I be learning?
No, you need to learn ST microelectronics, XT based microcontroller or TI based microcontroller. This was widely used in the industry. Okay, ESP is just for prototyping and a very miniature deployment we can do. But if you are going for a large scale deployment, again you need to go for a Nordic semiconductor for Bluetooth low energy.
Can you repeat which semiconductor?
Nordic semiconductor. ST microelectronics, TI, Texas Instruments. These three are widely used in industry.
Okay, sir. Thank you.
Okay, I think students have asked also, and we don't have much of time. So,
Okay.
Karthikeyan, thank you very much for delivering such a wonderful lecture, wonderful talk.